Good morning, dear students. My name is Ferhan Mazher, and today is 30th November 2021. And right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. It's Cambridge O levels of physics. And today we have set our hearts to solve MCQ paper. We have selected May-June 2008 paper 1. And this paper has 40 MCQs, and the time allowed to solve this paper is 1 hour. So you have to attempt 40 MCQs in 1 hour. So let's try this paper and hope you will understand this. So here we go. May-June 2008 multiple choice question. Physics 5054 and O levels physics. Time allowed 1 hour, 40 questions, and you have to do them. What is the reading on the micrometer? What is the reading on the micrometer? So this is the horizontal scale, and you can see this circular scale has moved how much on the horizontal scale. This is 1, 2, 3, 4, 5, 6, and this is 6.5. So it has moved 6.5. So in your rough work, you will note down 6.5, and then you will note down that which line on the circular scale coincides with this horizontal scales. So this line is matching, so that is 13th. So 6.5 plus 0.13, you just add them, and that will give you 6.63 millimeter. So the reading is 6.63 millimeter. So I think that the B is the right choice. I think B is the right choice. So let's check the answer. Question number 1, B is the right choice, sir. Okay, so let's go to the next question. Okay. Two forces, F1 and F2, act on an object O in the directions shown. What is the direction of the resultant force? So here you have two forces, F1 and F2, and you want to find out their resultant. I will use parallelogram law to find the resultant. Let me show you my work. So here we go. So these two forces, they need to be added. Their tails are joined, and in the parallelogram, the vectors to be added, they have to be put in such a way that their tails are joined with each other. Then we suppose that they are the adjacent sides of a parallelogram. So we suppose that these are the adjacent sides of parallelogram. So OF1 parallel to this, I draw a line here. And OF2 parallel to this, I draw a line here. So I complete this parallelogram. Then where the tails were joined, I join it with the opposite corner of the parallelogram. And that blue line is my resultant. So this is how you find the resultant of two vectors with the help of parallelogram law. So I think D looks the best option. What is the direction of the resultant force? I think D is the right answer, sir. I think D is the right answer. So let's check from the marking scheme. So we think that D is the right answer. Okay, so let's have a look at the marking scheme. Question number 2, D is the right answer. A wooden block is pushed across a table at constant speed. This word is very important. It's being pushed and the speed is constant. So this is the wooden block. This is the pushing force. This is table. Which statement is correct? The frictional force increases as the block moves at constant speed. No. The frictional force, when you move at a constant speed, the forward and backward force, they will be equal to each other. The resultant force will be 0. That's why the body is moving at constant speed. So the frictional force is equal and opposite to the pushing force. I think this is the right answer. So let's check question number 3, B B. Question number 3, B is the right answer, sir. Okay. Let me reduce the size so you can see the whole thing. Okay. Skier is traveling downhill. The acceleration on the hard snow is 4 meters per second square. And on the soft snow is 2 meters per second square. Which graph shows the motion of the skier when moving from hard snow to soft snow? So here in the options, you have 4 A, B, C, D options, and you have speed time graph. In the speed time graph, you know, the slope of the speed time graph represents the acceleration. So he was moving on the hard snow, then on the soft snow. On the hard snow, the acceleration is 4 meters per second square, and on the soft snow, the acceleration is 2 meters per second square. On the hard snow, the gradient of the speed time graph will be positive, and it will be steeper, it will be larger as compared to the gradient of the speed time graph on the soft snow. So in the first portion, the gradient will be constant and it will be larger. And in the second portion, the gradient will be lesser, but it will be positive. So I think C is the best option. You can see that here the gradient is larger as compared to this portion, and it's positive in both the portions. The gradient is positive. So here, and we can find the gradient here. It's 20 divided by 5, and that will be 4. And from 20 to 30. So I think C is the best option. Without any doubt, C is the best option. So let's check. Question number 4, C is the right option, sir. What keeps an electron moving in a circle around the nucleus of an atom? You see, electron is negatively charged and the nucleus has positive charge. So they have electrostatic force of attraction between the positive charge and the negative charge on the electron. So the centripetal force is being provided by the electrostatic force of attraction, and direction of that force will be towards the nucleus. So what keeps the electron moving in a circle around the nucleus of an atom? And electrostatic force towards the nucleus. I think D looks the best option, sir. Question number 5. D is the right answer, sir. Question number 5. D is the right answer. A lump of metal has a mass of 210 grams. It is lowered into a measuring cylinder containing water. The level of the water rises from 35 centimeter cube to 140 centimeter cube. What is the density of the metal? So we know the mass of the metal, that's 210 grams. Here we have a measuring cylinder. It is filled with the water. The volume here is, this is 10, 20, 30, 40, 50. So it's like 35 centimeter cube. And when you put that metal into the measuring cylinder, the volume is 140 centimeter cube. So this is V1, this is V2. If you subtract V1 from the V2, you will get the volume of that metal. You know the mass of the metal, you know the volume of the metal. So you can find the density very easily. The density is equals to mass divided by volume. So let me show you how I have done this. And okay, so the mass of the metal is 210 grams. The V1 is 35 centimeter cube. V2 is 140 centimeter cube. So the volume of the metal will be V2 minus V1. It will be 140 minus 35, and that will be 105 centimeter cube. So the density will be mass divided by volume. We know this is the formula for the density. So it will be 210 grams divided by 105 centimeter cube. So when you divide 210 with 105, you get 2 grams per centimeter cube. 2 grams per centimeter cube. 2 grams per centimeter cube. So let's check. 2 grams per centimeter cube. So we think C is the choice. Question number 6. And C is the right choice. Yeah. An extension load graph for a wire is shown. And what is the load at the limit of proportionality for the wire? So the load at the limit of proportionality means the point up to on the extension load graph. Up till that point, the extension load graph is the straight line. Extension and the load, they are directly proportional. And after that point, the extension load graph becomes a curve. And the extension and the load is no more directly proportional to each other. So let me increase the size so you can see it more clearly. So up to what point? So here you can see. So I hope now it's more visible to you, that extension load graph, and up to what? Yeah, up till here, it's a straight line. The gradient is constant. Extension and load, they are directly proportional to each other. After this point, it has started curving upward. So what's the load here? And that's 60 Newton. The load is 60 Newton at the point of limit of proportionality. The load is 60 Newton. So hopefully you understand how we have done this. So 60 Newton. I think C is the choice. Question number 7. Question number 7, C is the choice. A flat lamina is freely suspended from the point P. The weight of the lamina is 2 Newton and the center of the mass is at C. PC is equals to 0.50 meter. PQ length is 0.40 meter. The QC length is 0.30 meter. The lamina is displaced to the positions shown. What is the moment that will cause the lamina to swing? Okay, so here is the pivot. Here you have put a nail and this lamina is hanging with this from this nail. And here is the center of gravity of this lamina. So here we will have here the weight is acting. So the line of action of the weight will be like this. Let me show you and let me try to explain it to you. Okay, so this is the pivot, and here the line of this red line is basically showing the line of action of the weight. And you know, the perpendicular distance between the pivot and the lamina is this blue line, which is equals to the QC. So because pivot is here, the weight is acting on the right side and it's acting downward. So it will produce a clockwise moment, and we can find the magnitude of that moment. The weight of the lamina is 2 Newton, that was given in the question. And the blue line, which is the perpendicular distance between the line of action of the weight and the pivot, and this blue line is equals to the QC. So I can use the QC length, that is 0.30. So 2 Newton multiplied 0.30 meter will give you the moment. You multiply them, you get 0.60 Newton meter. 0.60 Newton meter clockwise moment. So let's check what happens. What's our if our answer is right or not. 0.60 Newton clockwise. So we think that A is the right option. So let's check. Question number 8. A is the right option. So hopefully you understand the question. A ball is held at rest on one side of a curved track. So this is the starting point. So this is a curved track. So when you release the ball from here, the ball will go here and then it will come back and it will go here and it will come back. So at this point, it has stopped the ball is released. It rolls down one side of the track and part of the way up the other side, sorry. It then stops before rolling back down again. The height of the stopping point is less than that of the starting point. So whatever is the height here from the ground, the height at this stopping point from is less. What is the sequence of energy changes between starting and stopping for the first time? So when the ball will be here at the maximum height, it will have the potential energy. And when you let the ball go down, that potential energy will convert into kinetic energy. And with this, the heat will be produced. And then when the ball will go upward, it will be gaining potential energy and some heat will be produced because there will be friction. There will be friction between the track and that ball. So when the ball is going down, the potential energy is converted into kinetic energy and some heat is produced. And when the ball is going up, the kinetic energy will convert into the potential energy and some heat will be produced. So I think D looks the best option to me. That and why we are so much sure that the heat is produced, because the height from where the ball was released and the stopping point is not at the same height. Its height is less. So it means some energy has been lost, and that will be in the form of heat. So I think D is the right option, sir. So question number 9, I think D is the right option. So let's check question number 9. D is the right option, sir. Okay. A workman rolls a barrel of weight 2000 Newton up a plank of length 2 meter and onto a lorry. The back of the lorry is 0.80 meter above the horizontal surface of the load. What is the work done on the barrel against the gravity? The work done in this case, when something has moved vertically upward, we can calculate the work done by the formula. Work done is equals to weight multiply the vertical height gained. Weight multiply vertical height gained. Here the weight is 2000 Newton and the vertical height gained is 0.80 meter. So let me show you how I have done this numerical, and that will be helpful to you. Okay. So the weight is 2000 Newton. The vertical height gained by the barrel is 0.80 meter. The work done will be weight multiply the vertical height. So 2000 multiply 0.80, and that will be 1600 joules. It will be 1600 joules. So let's check. Question number 10, 1600 joules, and we think that B is the right choice. Yes, sir. Question number 10, B is the right choice. Energy from petrol is used to operate an engine. The engine drives a generator, which produces electric energy. So here we have a block diagram. It says that energy from the petrol is 400 joules. It is given to the engine. And engine work done by the engine is 120 joules, and which is fed to the generator, and the generator gives out 100 joule electric energy, 100 joule electric energy. What is the overall efficiency of the process? So the overall efficiency of the process will be useful electric energy divided by the total input energy of the petrol multiply 100. And that will give you the overall efficiency. So let's do my calculation. Okay. So the input energy here is 400 joules. A useful output energy is 100 joules. The efficiency formula is useful output energy divided by input energy multiply 100. The useful output energy at the generator is 100 joules, and the input energy, total input energy is 400 joules. So multiply 100. So the final answer will be 25%. So the overall efficiency is 25%. The overall efficiency is 25%. So let's check question number 11. 25% we think is the answer. Yeah, we have this option here. That's option A, question number 11. So let's check. Let's check if we have this question number 11. A is the right choice, sir. Which statement about the pressure in a column of liquid is correct? Which statement about the pressure in a column of liquid is correct? It acts only vertically downward, maybe. It acts in all directions, basically. It increases if the column width increases. That's wrong. It increases with the depth in the column. That is perfectly right sentence. The pressure of the liquid depends upon rho GH, where GH means the depth of the liquid above the point of observation. It increases with the depth in the column. That is true. It is uniform throughout the column. That is not true. As you go deep, the pressure increases. So it increases with the depth in the column. That's the best answer, I think. Which statement about the pressure in a column of liquid is correct? Okay. It acts only vertically downward. That is no, it acts in all direction, I think. It increases if the column width increases. That is wrong. It increases with the depth in the column. That is true. It is uniform throughout the column. That is wrong, because the pressure as you go deeper and deeper increases. So I think C looks the best option to me. It increases with the depth. Question number 12. Let's check question number 12. C is the answer. What is our choice? C is the right answer, sir. An airtight container holds a fixed quantity of gas. Its pressure and volume are measured on 4 occasions. When the temperature is 20 degrees centigrade, the results are shown in the table. Which set of reading is incorrect? So we are looking for that reading which is incorrect. Okay. So you see the temperature is constant here, 20 degrees centigrade. So we are talking about a gas. So if the temperature is constant, the gas will have the product of the pressure and the volume will remain constant. So P1 V1 will be equals to P2 V2 equals to P3 V3, and that will be equals to P4 V4. So if the product of the pressure and volume will remain constant, that will be correct value. If anywhere you find that the product of the pressure and the volume is different, then that will be the incorrect value. So question number 13. So let me show you. I have done this calculation. Okay. So okay. P1 V1 120 into 36. That's 4,320. P2 V2, that's 100 into 48, that's 4,800. P3 V3, that's 80 into 60, and that will be 4,800. P4 V4, and that will be 60 into 80, and that will be 4,800. So you can see the product of the P, the pressure and the volume remains constant, but in the first value, the second value, third value, fourth, the product of the pressure and the volume is same, but the first value has a different product. So that is incorrect value. So I think the first one is incorrect. The A part is incorrect. So we were supposed to select the one which is incorrect, and I think that's A part. So A part is incorrect, basically. So let's check. Question number 13, A is the answer. Yes, A is the answer, sir. Okay, so in a vacuum flask, which methods of heat transfer are prevented by the vacuum? So vacuum can stop convection, the vacuum can stop conduction. The vacuum cannot stop radiation, remember that. So which methods of heat transfer are prevented by the vacuum? Conduction and convection only. The vacuum cannot stop radiation. Okay, so question number 14, I think C is the right answer, sir. Yep. The C is the right answer. Question number 14. The diagram shows a liquid in glass thermometer. At 0 degrees centigrade, the length of the liquid column is 2 centimeter. So L0 is 2 centimeter. At 100 degrees centigrade, the length of the liquid column is 22. At 100 degrees centigrade, the length of the liquid column is 22 centimeter. What is the length of the liquid column at 40 degrees centigrade? So when the temperature will be 40, what will be the length of the liquid column? It's a very famous question. So let me show you how I've done this. Okay, so the theta naught, that's 0 degrees centigrade, theta 100, that's 100 degrees centigrade, theta 40 is 40 degrees centigrade. L naught is the length of the mercury column when the temperature is 0, that's 2 centimeter. L100 means the length of the mercury column when the temperature is 100, so that's 22 centimeter. L40 means the length of the mercury column when the temperature is 40, and that is question. And you know the famous formula is this: L40 minus L naught divided by L100 minus L naught, theta 40 minus theta naught divided by theta 100 minus theta naught equals to L40 minus L naught divided by L100 minus L naught. Just put the values here. So the 40 minus 0 divided by 100 minus 0 equals to XL40. What's the length of the mercury column when the temperature is 40? I don't know that, so I suppose it as X. So minus L naught is 2 divided by L100 is 22 minus L naught is 2. So you will have 40 divided by 100 equals to X minus 2 divided by 20. So X minus 2 will be equals to 800 and divided by 100. And you will have X minus 2 equals to 8. So X will be equals to 8 plus 2. X will be equals to 10 centimeter. So the length of the mercury column when the temperature is 40 will be 10 centimeter. The length of the mercury column will be 10 centimeter. So let's check. The length of the mercury column will be 10 centimeter at the temperature of 40 degrees centigrade. So let's check. Question number 15. Question number 15. D is the right option. We have also taken the D option. Question number, sorry, I was saying question number 14. That's question number 15. And its choice is D. Okay, so here we go. At regular intervals along a railway line, there is a gap between the rail sections. What is the reason for the gap between the rail sections? So whenever you put two sections of the rail on the railway track, you always leave this gap. The reason is when it will be hot, these rails, which are made of the iron, they will expand. So you leave a little space between the two rail sections. So whenever they expand, here you have left some space for that expansion. If you will not leave this space, when the weather will become hot, the iron rails, they will expand, and because when there will be no gap between the rail sections, the rail sections will become tilted. So they become twisted. And what's the reason for the gap between the rail sections? To allow for expansion of the rail sections during the hot weather. That looks the best option, sir. And that's the reason. To allow for vibrations of the rail section as the train passes over them. To allow rainwater to drain from the rail sections. To keep the wheel of the train and the carriages on the rail section. So A looks the best option to me. Question number 16. Question number 16, A is the right option, sir. Okay. Ice is taken from a freezer and left in a room. The ice melts and eventually the water reaches room temperature. Which energy transfers takes place? So energy transfer during melting. So when the ice is melting, the energy will be changing from, it will be being transferred from the room to the ice, from the room to ice. And energy transfer after melting, so it will be the ice, the water, that will be still very cold, and we believe that the temperature of the room will be higher, so it will be still from room to water. Okay, so first it will from water to the ice, then it will be from room to water. So I think C is the best option, that the heat will be transferred during the melting from the room to the ice, and energy transfer after melting, that will be still from room to water, because the water will be very cold, so it will absorb the heat from the surrounding. So question number 17, C looks the best option to me. Okay, the C is the right answer, sir. Some air is trapped inside a small balloon. The average kinetic energy of the air molecules in the balloon is measured. What remains the same? The density of the air in the balloon, the mass of the air in the balloon. Yes, the mass of the air will not change. The temperature of the air in the balloon, the volume of the air in the balloon. So the one thing which will not change is the mass of the air in the balloon. So that's the B choice. Question number 18, I think B is the right option. Question number 18, B is the right option, sir. A student is investigating the evaporation of water. The student can change the depth of the water, the surface area of the water, the temperature of the water. How many of these changes, if any, would alter the rate at which the evaporation occurs? So you see, the depth of the water has no effect on the rate of evaporation. So the surface area of the water, that definitely has effect on the rate of evaporation, and the temperature of the water, that also affects the rate of evaporation. So two of them can affect the rate of evaporation. The first one, which is the depth of the water, do not affect the rate of evaporation. Okay, so I think 2C is the right answer. So there are two things which can alter the rate of evaporation. Okay, so I think C is the right option. Question number 19. Question number 19, C is the right option. And the diagram shows different views of a water wave in a ripple tank. Which latter represents a wavelength and a wavefront? Okay, so the wavelength, these lines, this basically are showing the wave fronts. So the wavefront is this R, the wavefront is R, and the wavelength is the horizontal distance between the one crust and the consecutive next crust. So P is representing the wavelength, and the wavefront is represented by the R. S is also representing the wavelength, but it has not been given in the options. So the wavelength is P and the wavefront is R. So I think A looks the answer to me. That's the first answer. And it's right. Question number 20. Let's check. A is the right option, sir. A ripple tank is used to demonstrate refraction of the plane water waves. A ripple tank is used to demonstrate refraction of plane water waves. Waves in deep water have a wavelength of 1.2 centimeter and a speed of 9.6 centimeter per second. The wavelength of the waves in shallow water is 0.8 centimeter. The wavelength of the waves in shallow water is 0.8 centimeter. What is the speed of the waves in the shallow water? So that is the question. So here you know the speed, here you know the wavelength. I can find out the frequency here. Whatever will be the frequency here, same will be the frequency here, and I know the wavelength here. If I know the frequency here, I can find the speed in the shallow water. Okay, so let me show you how I've done this. So in the deep water, the speed is 9.6 centimeter per second. The wavelength is 1.2 centimeter. So I can find the frequency in the deep water. The frequency, V is equals to F lambda. So F will be V divided by lambda, and that will be 9.6 divided by 1.2, and that will be 8 hertz. So in the shallow water, the wavelength from the diagram I can tell is 0.8 centimeter, and the frequency will be, the water will have the same frequency, so it will be at 8 hertz. Their question is, what is the speeds? The V will be equals to F lambda, where F is 8 and lambda is 0.8. So when you multiply them, you get 6.4 centimeter per second. So the speed will be 6.4 centimeter per second. 6.4 centimeter per second. So let's check. 6.4 centimeter per second, and I think A is the right option, sir. Question number 21, A is the right option. Question number 21, A is the right option, sir. A ray of red light enters a semicircular glass block normal to the curved surface. Which diagram correctly shows the partial reflection and refraction of the wave of the ray? So partial reflection and partial refraction is supposed to be shown. So we have to choose which one is the correct path. Okay, so let me show you my work. So this is that first diagram. So I have drawn here a normal. That red line is showing the normal. So you can see that the angle of incidence is larger, angle of reflection is smaller. So this cannot be the answer. In the B part, I have drawn this normal. You can see that the angle of incidence is larger, but the angle of reflection shown here is smaller. So that's a wrong diagram. Here you can see that when I draw normal at this point, the angle of incidence and angle of reflection, they both will be equal. But you see, when the light entered from glass into the air, the light moved from the dense medium into the rare medium. So the light was supposed to bend away from the normal. But in this C diagram, the light has bended towards the normal, which is against the nature of the light. So C cannot be the answer. In the D part, you can see here when I draw normal at this point, the angle of incidence, angle of reflection, they appears to be equal to each other. And when the light entered from a dense medium, which is glass, into air, which is rare medium, the light is supposed to bend away from the normal. So you can see here it has bended away from the normal. So I think D looks the best option to me. Question number 22, D looks the best option. Question number 22, I think this D part is the best option. Question number 22. Let's check. D is the right option, sir. An object 5 centimeter high is placed 2 centimeter from a converging lens, which is convex lens, which is being used as a magnifying glass. The image produces 6 centimeter from the lens and is 15 centimeter high. So what is the focal length of this lens? So we have to do construction on it on this diagram. So let me show you how I have done this. Okay. So here you can see this light ray which passes from the optical fiber. I have prolonged it behind until it touches the head of the image. And then we have taken another line, and because you see this came parallel and then it bended and it will go from the focal point. And I will prolong this line behind the object, and that these two lines, they will intersect here. So this will be your image. So in the same direction, I joined this point with this point and I prolonged it. So when it cuts the principal axis, so I check what's the reading here. So here we have 3 centimeter. So so what is the focal length of the lens? That is 3 centimeter. So I think B looks the best option to me. Okay, so question number 23. B is the right option, sir. Question number 24. A man is short-sighted. Which ray diagram shows what happens when he looks at a distant object? So when you are short-sighted, your eye lens starts bending too much. So the light rays will cross each other before the retina. They are supposed to be crossing each other or focusing on the retina. But when somebody becomes short-sighted, the lens of the eye starts bending the light rays too much. So what happens? They make the image before the retina. So his question is, which ray diagram shows what happens when he looks at a distant object? So I think C is the right option, sir. Question number, we have question number 24, C looks the best option to me. Question number 24, C is the right option, sir. Which color, red or blue, has the higher frequency and which has the longer wavelength? So remember this code word. Here we have a code word. Let me write that code word here. The code word is, it's Roy G. Biv. So the code word is Roy G. Biv. And as you go down in this list, the frequency will increase. And the red has higher wavelength. And as you go down, the wavelength will decrease, but the frequency will increase as you go down in this list. So higher frequency, the blue will have higher frequency as compared to the red, and the longer wavelength will be of the red. So higher frequency will be of the blue and the longer wavelength will be of the red. So I think B looks the best option to me. B looks the best option. Question number 25. B is the right option, sir. Waveforms are shown on a cathode ray oscilloscope for a flute and a guitar playing the same note. The oscilloscope settings are the same for both waveforms. What is the difference between the two sounds? You can see that they have the same. If you will try to calculate the time period, they will have both the waves have the same time period. So it means they have the same frequency. And you can also see from the mean position how high they have gone. So they will have the same amplitude. The only difference between them is the basic shape of the wave, sound wave. That's difference. And that basic shape, the difference of the basic shape, on that basis, we are able to distinguish between a guitar and a piano and the different people, their voices, we can differentiate between them. And so that is called quality, timbre, timbre. We call it timbre, the quality, because the basic shape of the sound wave is different from each other. That's the main difference between them, the quality. Call it the quality. Question number 26, C looks the best option to me. Question number 26, C is the right option, sir. The diagram shows how a steel bar can be magnetized. Which statement describe how the steel bar can be demagnetized? So the steel bar can be demagnetized. For demagnetization, we always use alternating current. Remember, for demagnetization of a bar magnet, we always use alternating current, and you can gradually decrease the current, and that iron bar will lose its magnetism if it has been magnetized. Use an AC supply and gradually decrease the current in the circuit. Yes, that is how you demagnetize the steel bar using alternating current. So C, question number 27, I think C is the right option, sir. Question number 27, C is the right option, sir. Okay. A perspex rod can be charged positively by rubbing it with a woolen cloth. How does the rod gains its charge? Okay, so so the rod is rubbed with the woolen cloth, and the perspex rod has become positive. So because it has positive, it has become positive. That means it has lost electrons. The woolen cloth has gained electron. So the rod has lost electron. So I think the rod loses electron. That's the reason it has become positive. So I think C is the best option, sir. Let's check. Question number 28. Question number 28, C is the right option, sir. Question number 29 is showing up on your screen. Which diagram correctly shows the electric field lines between the 2-point charges? From the positive charge, the electric field lines should come out, and into the negative, the electric field lines will go in. From positive, they come out, and from in negative charge, they go in. So I think B looks the best option to me. The B option looks best option, which is representing the electric field lines. Question number 29, B is the right option, sir. Three identical heating elements are wired up to the mains supply in the three arrangements shown. In which arrangement is the current from the supply lowest, and in which is the highest? The current will be lowest when the resistance of the combined resistance will be highest. So when you connect the resistors in series, when you connect the heaters in series, and then the heating elements connected in series, their resistance will add up, and their combined resistance will be largest. So in that case, the current will be lowest. So the lowest current will be in X. And then in the Y case, you can see that the elements, they are connected in parallel to each other. And whenever you connect the resistors in parallel, their combined resistance will be very low. So the combined resistance will be even lowest. So his question is, in which arrangement is the current from the supply lowest? I think Y. In the Y, the current will be, in Y, the current will be highest because the total resistance, combined resistance will become lower. So Y, the highest current will be Y, and lowest current will be X. I think B is the right option. Question number 30, B looks the best option to me. And question number 30, B is the right option, sir. The diagram shows the components of a lighter of a gas cooker. Which circuit diagram is the correct for this lighter? So here you have two cells, and then here you have a switch, and then you here have that heating thing, that resistor which will start glowing due to the heat. Which circuit diagram is correct for this lighter? And so you have battery, you should have a switch, and I think A looks the best to me. Cells are connected properly. Here we have the switch, and then you have that resistor. This looks not good to me because this battery, one portion of the battery is here, the other portion is here. and between them you have connected a switch, and that does not look good. And which circuit diagram is correct for the lighter? Okay, so I think A looks the best. uh, C is wrong because it has not shown two cells. This is wrong because they have connected, that is good, but this they have shown here that the switch is separate and the resistor is here, which is wrong. So I think A is the right choice. Question number 31. A is the right option, sir. In each of the circuits below, there is a short circuit. In which circuit does the fuse blow and make the circuit safe to repair? Fuse must be connected in the live, and the short circuit must happen after the fuse. Means the fuse must be in the live, and the short circuit should happen after where you have installed the fuse. So the fuse is in the live and it's before the short circuit. So I think this is the answer. And this is not the right answer because the fuse has happened before the fuse. The fuse is after the short circuit. So this fuse will not be able to do any good. So here you have a short circuit and you have put the fuse in the neutral wire, which is wrong. The fuse cannot be in the neutral wire. So I think A is the choice. Question number 32. Question number 32, A is the right option, sir. The diagram shows a simple electric motor. The split ring commutator reverses the current in the coil as the coil rotates. The coil is rotated 360 from the position shown. How many times is the current in the coil reversed? So the current will reverse its direction, I think, for 2 times. So in complete revolution, the current direction is changed 2 times. So I think B is the right option as a conceptual question. And this is the split ring commutator. So when it's rotating, the direction of the current will be changed 2 times. Question number 33, B is the right option. Question number 33, let's check. Yeah, B is the right option, sir. A conductor is moving horizontally across, sorry, a conductor is moving horizontally across a vertical magnetic field. An EMF is induced in the conductor. No deflection is seen on the ammeter. What is the reason for this? Because the EMF is induced, but the ammeter has shown no deflection. It means that you are moving that conductor very slowly. You are moving that conductor very slowly, and due to this, the current which is produced in that conductor is not enough to show the deflection on the ammeter. So the ammeter is not being the ammeter is not between the poles. The conductor is moving too slowly. That is the reason. The conductor is not cutting the field lines. No, it's cutting the field lines, but it's moving very slow. The poles are too close together. No, that's not the reason. So I think the conductor is moving too slowly. That's why the amount of current which is produced in the conductor is very short. So I think question number 34, B is the right option. Yeah, B is the right option, sir. Oops. The diagram shows 3 generators. So you can see this is slip ring commutator. So this is a generator. This is split ring commutator. So this is motor. This is the famous dynamo, which produces electricity. So which are alternating current generators? Okay. So dynamo produces and the X also produces electricity. So I think X and Z. Question number 35. D. Yeah. Our answer is right. Question number 35. D is the right option, sir. Which transformer arrangement produces an output voltage that is larger than the input voltage? So this happens in the step-up transformer, and you can recognize the step-up transformer by just looking at the number of turns of the coil. So on the output side, the number of turns should be more than the number of turns on the input side. So that will be a step-up transformer, and it will increase the voltage, output voltage. And one thing you should remember, that the transformer is always connected with an AC supply. So I think B looks the best option, sir. Here you have alternating current, and the number of turns on the secondary coil, they are larger. So the output voltage will be larger. So I think question number 36, I think B is the answer. Yeah, question number 36, B is the right option, sir. Okay. The diagram shows a thermistor connected in a potential divider circuit. Okay. The resistance of the thermistor decreases when its temperature rises. The thermistor is heated. What happens to the potential difference across the thermistor as it is heated? So when you will heat the thermistor, its resistance will drop. So because its resistance will drop, so the voltage V out, which you have taken from the terminals of the thermistor, that will also drop. What happens to the potential difference across the thermistor as it is heated? It decreases, but not to zero. Yeah, that's right. If the R resistance of this will decrease, the voltmeter reading will also decrease. But it will not become zero, I don't think. So A looks the best option to me. Question number 37, A is the right option. Yeah. Which travels in a straight line across a magnetic field? So, you know, the alpha and the beta, alpha particles and beta particles, they are charged particles. So magnetic field has effect on them. But the gamma rays, which are electromagnetic in nature, the magnetic field has no effect on it. So gamma rays, which travels in a straight line across a magnetic field, and that is gamma ray. Question number 38, C is the option, sir. Yeah. Question number 38, C is the right option. In the treatment of brain cancer, a patient's head is enclosed in a helmet containing a number of radioactive sources. The radiation from each source is directed towards the cancer. Which nuclide is most suitable for these sources? And the half-life should be very large, and it should be producing some radiation, which can pass through the bone and which can pass through the skin. He says, cesium, and that's cesium-137, which produces gamma radiation, and it's 30 years half-life. The half-life should be very large. So I think this looks the best option. Beta might be stopped by the bones, and its half-life is 15 hours only. And due to this half-life, we cannot use it because you have to buy it again and again then. So I think A is the choice. Question number 39. I think A is the choice. Question number 39, A is the right choice, sir. Question number 40. A nucleus of the element cobalt may be represented by the symbol 2759 cobalt. What is the structure of this nucleus? So in the nucleus, you will have protons. There will be 27 protons. And the number of neutrons will be mass number or nucleon number minus the proton number. So 59 minus 27, that will be 32. So the protons will be 27 and the neutrons, that will be 32. So I think A is the right answer, sir. For question number 40, A is the option, I think. Let's check. Question 40A is the right answer. So, my dear students, by this question, we have done with the 40 questions. So today we have solved May-June 2008 MCQ paper, and I have tried my best to explain the concepts. I hope that this video will help you. It will improve your physics concepts if you find this video helpful. And subscribe to my YouTube channel and also like this video. And if you think that this video can help you and it can also help your class fellows, your juniors, your seniors who are studying in O-levels, don't hesitate to share the link of this video onto your Facebook account and onto your Instagram. That will be a great appreciation for me. So thank you very much. It's a pleasure teaching you all. Thank you very much once again, and have a good day, and God bless you all.